The lesson video for 8889. You're going to watch the video, pausing it where I tell you to and completing some things. And what you're looking for is a shorter way to do certain types of factoring. The good news is the shorter patterns or the shortcuts don't have to be done to get good correct answers. You can continue to use the factoring diamonds and the patterns that you've already established with these problems as well. So what I want you to do is pause the video and complete the 6 multiplications that are shown on your 8889 notes, these 6. Okay, consider that they each need to be double distributed, meaning there are 2 terms multiplied by 2 terms. So pause and only come back when you have them all done. So I first want you to check them now that you're back. Okay, you should have paused the video to complete each of these. You should not just be writing them in for my answers. And what we're hoping to see, and the big idea, is 2 patterns are emerging. And we looked at these 2 patterns in the last unit. We'll use these patterns in reverse to look for some factoring shortcuts. Like I said, the good news is these shortcuts are wonderful if you see them. If you don't see them, our other ways of factoring will still work. But in the last unit, you guys noticed that when you multiplied out 2 of the same factor, that a pattern always came up. You always came up starting with a perfect square and ending with a perfect square, x times x and 7 times 7. But in the middle, you ended up with 2 sets of 7x being added together, so you ended up with a number that was twice that 7. Same deal on the next one. You ended up with an x squared, you ended up with a positive 9, and then you ended up with 2 sets of negative 3x, which caused you to have a negative 6x in the middle. So we called that a perfect square trinomial. These would be good things to get on your note card before your unit test. And they always fit a pattern of, it was the number minus itself squared, or you could have the number plus another one squared. And they always came out to a pattern that it was always the first one squared, in this case minus, or in the other one a plus, twice the beginning and the end number, and the last one squared. In this case, it'd be plus 2ab plus, and I'm writing over the square, sorry about that, b squared. The other pattern that we saw was when you multiplied an expression and then the expression with the other sign in it, plus or minus, you always ended up having your middle terms drop out. So you had perfect square, and you always had a subtract sign. We called that one difference of perfect squares, or just difference of squares, because it was always a subtract situation and they were always perfect square on each end of it. So in math speak, we said if it's an expression and then an expression with the opposite sign, the first term will be squared, the last term will be squared, and there'll be a subtract, but those middle terms will zero out. So factoring methods you've already had. This is a review. Step 1, if you look at this table, it's just summarizing or telling you things you already know about factoring. Step 1, we're describing monomial factoring here. That should always be done first, unless our GCF is 1. You can do that with any number of terms, and they give you an example. We said step 2 is after you GCF factor, you might want to check for those 2 patterns that we just recognized. If you recognize them, you might be able to factor kind of quickly. If you don't, however, I would come down to step 3 and hang out in there where we've been factoring all along, turning trinomials into grouping, or if it was already 4 terms, just factoring it by grouping to begin with. So step 2 will be where we find a shortcut today and try to use it, but step 3 will be where we go if we don't see the shortcut and we don't recognize it. So on the next page, there's some practice ones. We're not going to do every single one of these. We're going to do some of them. The first one that says factor the m squared minus 64, there is no GCF other than 1, but the next thing I notice is that it is that pattern of perfect square minus perfect square. If I recognize that, I could go to its factors right away and say, well, what I remember is, I'm going back to your page if you need to, that would give me the m squared. 64 is 8 times 8, and I will have one of each sign as my factors. If you didn't recognize that pattern, you can still do this. So I'm going to leave in green what I recognized from the pattern, but I'm going to go back to a factoring diamond and say that my a value times my c value would be negative 64 for what my numbers have to multiply to make. There are no plain old m's, so what do my numbers have to add to is 0. So if I had this in ax squared plus bx plus c form, I'd have 1m squared plus 0 m's. So in other words, the two numbers in the middle have to knock each other out. So numbers that add to be 0 but multiply to be negative 64 would be negative 8 and positive 8. So if I didn't recognize the pattern that I wrote out in green, I would do a rewrite of my expression as m squared plus 8m's minus 8m's. That's what my factor diamond is telling me I can do. And then I would factor by grouping, and what you're going to see is we're going to get to the same place that we got by that shortcut. So if you didn't recognize the shortcut, our two sets would then factor and still finish up to be what's in the green. So the shortcuts are if you recognize them. On this one, with x squared plus 10x plus 25, if you recognize it, that is that factoring pattern that the beginning's a perfect square and the end's a perfect square. And the middle is two sets of that x that's the perfect square here and that 5 that was squared to get here. So if you recognize that, that would be one of those perfect square trinomials. And the factoring is that you have two identical factors of x plus 5 and x plus 5. If you didn't recognize that, and it's okay not to always see that pattern, I can still go back to my 1 times 25 is what I need my product to be, and my 10 is what I need my sum to be, and I would recognize those two as 5 and 5. So in blue, if I didn't recognize that right away, I could rewrite my expression. So you're either talking about what's in green or what's in blue. Green if you recognize the pattern, blue if you say, I don't recognize that pattern all the time. So I'll have to do it the way I know in a few extra steps. Non-factoring by grouping. Stop the video and do this yourself. Make sure you know what's going on. And my factoring by grouping would still end up with that green one as my answer. So these patterns, if you see them, are wonderful. If you don't, then you go back to the factoring kinds that you already know. So I want to look at the one right below this, and it's got 6x squared minus 96. My GCF here is not 1, so I actually want to start by monomial factoring. So I notice that they're each divisible by 6. You can check if you don't believe me. 6 times x squared would give me 6x squared, and 6 times my 16 would give me that 96. But we're not done. We want to see if that x squared minus 16 can be broken down anymore by the types of factoring that we know. So I'm going to leave that 6 holding on out front and see if I can binomial factor this into two groups. Go back to diamond factoring if you need to. Your diamond would look like this. Your diamond would look like negative 16 at the bottom, 0 at the top. So please go back and diamond and group if you need to. If you recognize this pattern, you'd say, well, that's two perfect squares being subtracted. That's a difference of perfect squares. I need to know what was squared to get x squared, what was squared to get 16, and I'll need one of each sign. Otherwise, go back and do it by grouping. You will get back to the same exact place. Let's go up to the top and try that one in the corner that we didn't try yet. See if we can find this one. So this one I see a GCF of 3b that they both have. So I want to check for GCF factoring every single time. If it's not 1, then I want to stop and actually take the GCF out. This one will be b squared minus 9 to begin my monomial. Then I have to keep going down my checklist. If I can factor the inside part of this more, then I should. And that is that factoring pattern of perfect square minus, and it has to be minus perfect square. B squared is a perfect square, 9 is a perfect square. So pulling those two values, and to make sure I have 0 as my middle term, that will be my factoring. Otherwise, go back to diamond factoring. There's plenty of others on here you can try for practice if you would like. The very final thing you're going to use this for then is all of your factoring is going to go back to solving those zero product property ones. So on this first one, either diamond factor or pattern factor, but it's already equal to 0. So I need to factor the side that isn't. I recognize that as perfect square minus perfect square, so I recognize my factoring right away. If not, please go back to diamond factoring to get that by grouping. And then thing 1 times thing 2 is equal to 0, so I'm going to go ahead and set each factor equal to 0, step 3. show my work, and solve and get my two solutions. And I'm skipping one step of my work that you won't skip. Okay. I'm going to go to this third one. In this third one, I've got to go back to the beginning of my steps, which are always my 3 steps for solving these quadratics. First of all, I have to get it equal to 0, and it's not. So I'm going to subtract 20x on this side, and subtract it on this side. And I've got 5x cubed minus 20x is 0. So step 1 is done, because we can only use this type of solving if we're equal to 0. Then it says factor. Okay, I've got to go through all my types of factoring in the order we put them on your note card. Monomial first. I recognize that 5 and x are both factors of my expression. Slow down the video if you need to so you can get these in. Then I see that this actually can factor farther because it's x squared, it's not just x's. So I'm going to keep my 5x here and either diamond factor this one. If you go to diamond factor it, your product will be -4 and your sum will be 0. Your factors will be this. Again, go back and factor if you need to. Then I have 3 things, thing 1, thing 2, and thing 3 that might be 0. So each one of these gets set equal to 0 to come up with the 3 possible solutions that our original equation could have. So here if I divide both sides by 5, here if I add 2, here if I subtract 2 would be my 3 total solutions. So as you go through, make sure, and we're leaving these other 2 for another day, but make sure only good algebra steps. Make sure you're using the guide at the top for those steps so that you can practice them, and make sure that you're using this as you practice on homework as a guide.